So, if you've ever tried to build an AI agent, you know this feeling, right? This frustration. You want it to go out on the web to do research, to learn, but it just keeps hitting a brick wall. The internet, literally the biggest library of information ever created, is surprisingly locked down for AI. Today, we're diving into a tool that just might be the key to unlocking it all.
This quote right here, it just hits the nail on the head, doesn't it? Anyone who's tried this has felt this exact pain. You either get a hard no, a 403 forbidden error, or you get something almost worse, this giant, messy glob of HTML code that completely clogs up your AI's brain and eats up all its context. It's a fundamental roadblock. All right, so let's really dig into this. What is actually going wrong here? I mean, why is something as simple as grabbing a web page so incredibly hard for an AI? This isn't just some small bug, it's a huge barrier that's been holding back what truly autonomous agents can do. This comparison just lays it all out so perfectly. On the left, that's the old way, the standard approach. You're getting blocked left and right, and even when you get through, you get this fire hose of raw HTML. Nav bars, ads, scripts, all the junk. This mess eats up your AI's processing power, its tokens, which costs you real money and just slows everything down to a crawl. But then you look at the right. That's the promise of a tool like Webclaw. It slips past the blocks and gives you clean, simple, useful markdown that an LLM can actually understand.
So that's the problem. It's a mess, it's expensive, and it's painfully slow. Now, let's talk about the solution. Time to meet the tool at the heart of all this, Webclaw. In a nutshell, Webclaw is a toolkit built from the ground up to solve this exact problem. The two key things to notice here are Rust-based, which is just code for it's ridiculously fast, and this is the big one, without a headless browser. See, a headless browser is basically a full copy of Chrome running invisibly in the background. It works, sure, but it's a huge resource hog and super slow. Webclaw just skips all that.
And this really gets to the heart of its philosophy. It's all about speed and efficiency. By running locally, it puts your privacy first. And here's the crucial part. It does everything with pure HTTP extraction. That means no heavy browser libraries like Selenium or Puppeteer bogging things down. Oh, and it's completely open source. You gotta love that.
Okay, so this all sounds fantastic in theory, but how does it actually get past those super aggressive anti-bot systems that stop pretty much every other script dead in its tracks? Well, the secret sauce here is really, really clever. The core magic is something called TLS, fingerprinting. The best way to think about it is like a digital disguise. Whenever your computer connects to a secure website, it does this little digital handshake to introduce itself. Well, anti-bot systems are now experts at spotting the weak, robotic handshake of a script versus the firm, confident handshake of a real browser. Webclaw's trick is that it's been trained to perfectly mimic the handshake of a real Chrome browser. So let's just walk through how that plays out. The web server, acting like a bouncer at a club, checks the handshake of everyone trying to get in. A basic scraper comes up with a generic, obviously fake ID and gets flagged immediately, blocked. But then Webclaw walks up, wearing a perfect disguise, and gives the exact handshake the server expects from a legit Chrome browser. The server just sees a real user and says, "Come on in." It's that simple, and it's incredibly effective. All right, so the theory is solid, it's fast, it's sneaky, but how does it stack up in the real world? Let's stop talking theory and look at some hard data. This is the Webclaw difference in action. Man, this benchmark chart just tells the whole story, doesn't it? First, look at extraction accuracy, 95.1%. That's way better than the other tools. Now, look at the speed. For a pretty standard page, 3.2 milliseconds. That's not just a little faster than a cloud service like Firecrawl at 500 milliseconds. That's a whole different league. And notice that TLS fingerprinting row? It's the only one that has it. That's the secret key. Plus, it's self-hosted and free. It's a powerhouse. And this number? This is the one that really matters for your wallet and your AI's brainpower. By cutting out all the junk code and giving you clean markdown, Webclaw slashes the data size by 67% on average. For your LLM, that means you can cram 3 times more actual information into its context for the same price. You get smarter answers while cutting your API costs. It's a huge win-win. Okay, now let's put it under some real pressure. What happens when you're trying to crawl a bunch of pages all at once? Well, Webclaw is pulling down over 32 pages per second. As you can see, that just blows past other popular frameworks like Scrapey. That super efficient, Rust-based, no-browser design really shines when you ask it to do some heavy lifting. So all this power is great, but how do you actually hook it up to your AI agent? That's where something called the Model Context Protocol, or MCP server, comes into play. Honestly, the easiest way to think of it is as a universal adapter. It's a standard way for AI coding tools like Claude Code or Cursor to talk to and use external tools, just like Webclaw.
And through that MCP server, Webclaw gives your agent a whole suite of incredible tools. We're not just talking about scraping one page. You can crawl entire websites, you can search the web and then scrape the results, do deep research across a ton of sources, you can even extract structured data. It's a complete web intelligence toolkit, and get this, 8 of these 10 tools run completely on your own machine. No API keys needed.
Okay, I'm pretty blown away. The benchmarks are amazing. The features are super powerful. So what's the catch? How hard is it to get this thing up and running for my own projects? Let's find out.
But first, just think about what this unlocks. You can finally give your AI agents legitimate, real-time web access for research. You could build systems to create clean training data to fine-tune your own models. Or imagine setting up a monitor to track your competitors' prices and content automatically. The possibilities are just huge. And getting started, it's almost ridiculously simple. That's it, that one command. You type npx create webclaw into your terminal, and a script automatically figures out what AI tools you're using, grabs the right version, and sets everything up for you. We're talking like a 30-second setup, from zero to scraping.
And that really brings us to the big final question, doesn't it? For so long, the messy, unpredictable, and walled-off nature of the web has been this massive barrier for AI. Tools like Webclaw are a huge step in tearing down that wall. It really makes you stop and think, what incredible things could your AI build if the entire web was suddenly, finally, an open book?